So thanks for joining this session. We will introduce you our ongoing effort started recently about foundation models for medical image segmentation. So in this session, I will start with the overview of our positioning, and then Pengfei will introduce us the current status of the model training strategy. And then Yucheng will explain the inference workflow and highlighting the integration with MONAI label, and that is with live demo. And finally, Michael will conclude this session with a call for actions. So, yeah, so the concept of foundation model is not new. There's the idea of transfer learning for a long time. That is pre-train the model on a data set and transfer the domain knowledge to the new tasks by fine-tuning on the new data set and target. More recently, this idea becomes popular as the large language models shows very promising results, and that is being trained on large amount of data. The outcome of the model significantly better than the previous model trained on smaller data sets. So this kind of a new paradigm for building models is also changing the way we create deep learning models in healthcare. So with foundation model trained with domain-specific knowledge from all the different modalities, medical images, text, genomics, or signals from all different sensors. So the model could be potentially very generic, powerful, could be adapted to a wide range of specific downstream tasks, for example, for generating clinical reports or for personalized medicine and robotic surgery. So with these promising directions in deep learning, there's a lot of progress in foundation models for vision tasks as well. For example, a segment anything model that is developed by Meta. It supports interactive segmentation with user-provided flexible prompts in real time. It was trained with dataset that is at a very large scale, and the training strategy also jointly collecting, refining high-quality annotations. So the images, the training data are selected from diverse topics and scenes. So the model has a good generalization capability to novel data as well. So supporting the use cases of few-shot or zero-shot learning. There's an effort of combining these vision models with large language models to create intelligent systems. So these kind of systems can quickly generate high quality or consistent image segmentation masks. So that is our motivation to build MONAI Vista. So Vista stands for Versatile Imaging Segmentation and Annotation Models. So here we have two ambitious goals. So first, we want to build a foundation model to speed up medical image segmentation, so as well as the interactive segmentation process. So the models should be able to work with flexible, intuitive prompts from human experts. It should support multimodality and to generate excellent performance for clinically relevant structure of interest. It should also be powerful enough to generalize to few-shot or zero-shot novel structures. And secondly, we want to establish this kind of data engine collaborative paradigm for building medical image AI. So leveraging all the platforms or frameworks that we've been building, we want to create an efficient flow for AI and human experts co-develop the new models and develop at large scale. So in this way, we can accelerate the development of AI-enabled applications. So to achieve these goals, we are thinking about the following aspect of the workflow. First, it requires large-scale diverse data sets, especially with high-quality annotations from the human experts. So the previously successful systems in the literature, they have demonstrated that this is one of the key elements for to represent the domain age. And we should also adopt high-capacity networks And this is to capture the complex visual concept and also possibly combined with the language models to explore the semantic meanings of the annotations. And also we will need efficient continual learning approach so that the model can always aggregate the domain knowledge without getting the previous ones. And so finally, to enable the entire workflow, we should set up a complete training system that is with highly customizable components and modules to address, for example, data privacy issues. So in this case, we propose a collaborative model. That is the training strategy, keeping the training data on the data partner's local system and only exchange domain knowledge via this model sharing system during the model training. And for these ideas, we're not starting from scratch. We've been building Project MONAI with years of active development with the community. We cover the end-to-end model development life cycle with state-of-the-art implementations. For example, later in this workshop, we will have a presentation about Auto 3D Seg, that is our state-of-the-art segmentation pipelines. And we also created user interfaces using MONAI Label that is integrated with popular open source solutions. So support different image annotation use cases. We focus on accelerating the labeling process and the user experiences. In terms of the collaborative model learning, as Holger mentioned earlier, the NVFlare could be the underlying engine driving the overall learning process. So it comes with the capability, for example, authorization, experiment management. These kind of features will address many of the practical concerns for the training process. So Vista model, so this is an effort for exploring the foundation models. It's a very early stage. It will benefit a lot from the collaborations with the experts from the community and from this conference. In the following demos, we will show you some very basic initial setup and things we've explored. We will continue to research in these directions. So as the starting point, we explored the training pipelines with the interactive signals and integration with MONAI Label, those graphic interfaces, and collaborative training strategies with federative learning techniques. These are work in progress. And apart from searching for better models, achieving better segmentation performance, we are also aware of these open issues. For example, data privacy, diversity or fairness of the data set, robustness or the model, how to make the model explainable. And so these are also important topics we keep in mind when we build Vista model. I think that's everything for the overview. Perhaps Pengfei can take over and describe the training strategy.
Sure. Yeah, I can continue the presentation. Let me share my screen. Okay, can you see my screen?
Yeah, we can see your screen.
All right,
there we go.
That's great. Hello everyone, my name is Pengfei. I'm an applied research scientist at NVIDIA, and I will continue the presentation and introduce more details about our MONAI Vista model. First, I want to brief introduce the MONAI, the meta-SAM, the segment anything model. This is designed and trained to be promptable, and so it has strong performance on a variety of segmentation tasks. So this figure shows the overview of the model architecture, and the SAM has three components: an image encoder, and prompt encoder, and a mask decoder. The image encoder is a vision foundation model containing about 100 million parameters. The prompt encoder is built upon a few convolution and embedding layers, only contain about 4,000 parameters. The mask decoder is also based on vision transformer, but it's lightweighted, only contain about 4 million parameters. So with the three components, the SAM can efficiently map the image feature and a set of prompts in prompt embeddings to produce a segmentation task. Next, I want to highlight several features of our MONAI VISTA model. First, the MetaSAM is trained on natural images and the lacks of the domain knowledge of the medical data. And the figure on the right-hand side shows some results of the MetaSAM on CT slides. And we try to place a single positive point on liver, or right left kidney, and even the vertebrae. And without the training in the medical data, the SAM just segment the whole slice as the foreground. And in order to successfully segment the liver, you may have to place 4 positive points at the liver boundary and one negative point to suppress the false positive prediction. So this requires considerable users' effort to use it for annotation. For our MONAI VISTA model, we fine-tuned this model, including the image encoder, prompt encoder, and the mask decoder on 3D medical data. Also, the second, the MONAI VISTA model introduced the class label prompt and enable the fully automatic inference on known classes. It also shows the potential of generalizing to the unknown classes. However, the MetaSAM or other fine-tuned medical SAM do not support such fully automatic prediction, since the points and the bounding box prompts do not associate with any semantic meaning. This makes them impractical as a annotation tool, especially for the 3D medical data. It is hard to ask users to click every single slice. So the third point is for MONAI VISTA model, in this release, we extend the original SAM to take 2.5D data. So our model can leverage the information from multiple slices. In addition, MONAI VISTA is based on MONAI Core and the MONAI Label, with the annotation support with the 3D slicer and OHIV for radiology. As part of the MONAI ecosystem, we have various supports from the MONAI community. Okay, let's see. These slides show the architecture overview of the MONAI VISTA 2.5D model. We can see the overall architecture is same as the original MetaSAM, and so we still can leverage the pre-trained weights from the original SAM, and those weights are still valuable, especially the vision, the foundation image encoder. It was trained on 1 billion masks, and from this figure, we also can observe 2K difference from the original SAM. The first one is our model takes multi-slices, 2.5D input. For example, the 9 consecutive slices. The image encoder is able to fuse the information from the multi-slices to the image embedding. And the mask decoder will predict the target mask for the center slice. The second difference is we introduced the class label prompts, which allows the MONAI VISTA model to do fully automatic inference, like a normal multi-label segmentation model. This can significantly reduce the annotator's efforts, even for current 2.5D model. We can first use the fully automatic inference to get the prediction for the whole volume, and then we allow users to use the point prompt to correct the undesired predictions. In this slide, we show more details about the class label prompt. Let's say we have a set of predefined classes as known classes. For example, 1 for spleen, 2 for kidney, 3 for liver, and each class is labeled by an integer. The bottom right plot shows how we create a class label prompt for kidney. Let's say we want to segment out the kidney, and the index representing kidney is 2. It is encoded by the embedding layer. And then the embedding layer works as a simple lookup table that stores embeddings of fixed dictionary. And the generated class label prompt has a shape like B by 1 by 256. Here the B is the batch size, and 256 is just the embedding dimension. So embedding dimension is the same as the encoded point prompt. So we can concatenate those two kind of prompts and feed them into the mask decoder, and to guide the segmentation task. Okay, let's move to the dataset and the training step. Here we conduct our preliminary experiments on total segmentator dataset. This dataset provides like 1,204 CT volumes. It's contain a total of 104 labels in 5 categories, including 59 in skeleton, 13 in cardiovascular system, 6 in gastrointestinal tract, and 10 in muscles. So it's a good starting point for our initial MONAI VISTA model. And in terms of the training step, for the training step, it can be mainly divided into 2 parts. The phase 1, single step training, and the phase 2, iterative training. For phase 1, we start from the original pre-trained SAM weights and push the fully automatic performance, using the class label prompt only to the desired range. Since this class label prompt is a newly added function. For the phase 2, we do the iterative training. We basically follow the original SAM's training setting. We initially randomly sample positive and negative points for the targeted mask, as well as randomly drop or add the class label prompt. Then additional points are sampled from the false, negative, or positive prediction in each iterative step. Okay, next, let's move to the preliminary results on the total segmentator dataset. Here we show 3 experiments. The experiment 1 only uses the class label prompt. Experiment 2 only uses the 1 positive point. And experiment 3, we use both class label and the point prompts. Here, the experiment 1 does not require the annotator's input, so it can automatically predict all known classes. Experiment 2 and experiment 3 requires annotators input. The required annotators like input the click points, they show the model's semi-automatic performance. We can see our model can achieve like 77.7, and in experiment 1, 79.1, in experiment 2, and 85.6 in experiment 3. We also notice that the class label prompt and the point prompt are complementary each other. For example, in the organs category, when we solely use the class label prompt, we can achieve like 85.9 in experiment 1. When we solely use 1 positive point, we can achieve like 81.7. Combine them together, we can achieve like 87.6, the best performance. And we are also aware of the limitation of the current model, especially the automatic performance in the skeleton category. For the major organs like spleen, kidney, liver, and the muscles, our model shows good performance and can achieve like about 90 mean deaths in 3D evaluation. However, for the skeleton category, the mean death is still low. It's 71.3. We are actively working on improving it. Lastly, I want to highlight some works in progress. We are still actively developing this project, and the first one is the MONAI VISTA 3D model. It is more suitable for 3D medical data, and it will support 3D or volumetric input to enable a larger field of view and reduce users' annotation efforts. The second one is the text-based class label prompt. It will support encoding the input text. For example, here a CT of liver as the class label prompt, and it will give the model a stronger ability to deal with ambiguity and generalize to new classes. And also, we are also working on supporting more predefined classes labels for the automatic inference by training the model on multiple data sets. It will give the model a stronger ability to deal with, strong ability, to generalize to more predefined classes. And due to the nature of the prompt-based segmentation, our model is capable, like partial label training can be easily applied to different data sets. All right, I stop at here. I think my colleague Yucheng will introduce more details about the MONAI label and show the demo of VISTA model. Yucheng, the stage is yours, and I stop here.
Okay, thank you. You can see my screen, right?
Yeah, we can see it.
Yep, let me continue on the VISTA integration. And thanks for joining the session. So next we're talking about the VISTA integration with MONAI label and how we can integrate these cool stuff for the prompt-based segmentation experience with MONAI label or some viewers like 3D Slicer or OHAV. Like in addition to a model we trained like Pengfei mentioned, so we also introduced MONAI VISTA as a platform solution for deploying medical segmentation foundation models. So we are based on MONAI label, and we design some APIs and design the sample apps that can fastly deploy or develop the prompt-based segmentation models into a user experience. So here I will briefly introduce MONAI label infrastructure. So there will be three main parts. So the first one is the MONAI label server, and the other one is most important is the clients and the GUIs, so users can get interactive with. And the other part is the data store. So currently we are integrating medical segmentation experience with 3D Slicer and OHAV. And in the future, we are integrating more viewers. So for the MONAI label side, so with the VISTA integration, so we design some info request of the prompts, so we can easily design the call flow to pass prompts between the clients and the MONAI label server. So you can see here is I put two example info requests here to show that how the class prompts and point prompts, the point clicks prompts can be passed through the MONAI label server and interact with the 3D Slicer or other viewers. So here you can see if we have only the class prompts, for example, like 5 classes here from 0 to 4, so we can pass simply a list. And if we have the point prompts, we can also pass the foreground, the background as positive, negative clicks, and pass to the MONAI label server and run or inference through MONAI label server and with GPUs. So here's a brief demo of a screenshot of how the 3D Slicer integration with MONAI label and VISTA looks like. So here we show a whole body CT scan here. We can segment almost everything with the total segmentation model. And we also designed a GUI here. So with the 3D Slicer, with MONAI VISTA, we can show them the model. We have the point prompts and the class prompts. To show a more detailed look like it. So the GUI here with the 3D Slicer looks like this. So we can fill the API endpoint to connect to the MONAI label server from the 3D Slicer. And then we can have the app and we have the segmentation editor. And also we have some VISTA functional panel here. So you can load any models with your developer one. and you can interact with the control point widgets and with the class prompts. And also we have the anonymity checkbox for dynamic outputs. Like typically users won't inference like all of the classes at the same time. So users can check the box and get the anonymity what they want. And also we have everything button here. So for the auto segmentation of all classes, and for the checkbox, the class prompt, we also have a class button so that we can do selective inference. Okay, let me quit the slides and let's quickly demo the 3D slicer and Vista integration. So here I have terminal open, and we can start the MONAI label server. So with command line, so the model here we developed is called Vista 2.5D with the Pengfei mentioned. So after the MONAI label server is up, we can jump to the 3D slicer part. And let me make it larger. So there's a 3D MONAI label plugin here. So after we connect it, so we can connect to the MONAI label server. So there's a next sample button. So we can load a CD scan. So to increase the response time, so here, similar to what we have seen in similar works, we're extracting the 3D volume embeddings from the loaded CT images here. So we are disentangling the image encoder with the decoder part. So the encoder part, we can get image embedding from the 3D volumes here. So you can see now we have already loaded the image embedding here, and then we can do spline segmentations. Before that, we can see that there are 104 classes here in the checkbox, but typically we do not need all of these at the same time. So probably we can see that, for example, we can see the spline. So we check the spline and we click the classes button here, and then we can get a spline segmentation with the loaded image. Let's make it the extra view here, and if we want more classes, we can check box like red and left kidney and a gallbladder here. So the first 4 classes, and it can give us 4 classes predictions. You can see that like the 2 kidneys, gallbladder, and the spleens. And in addition to that, for example, if we want to edit the current volumes, we can check box the liver. And we can place a control point and like a positive point. Like here, we place a single positive point with the class prompt. We can click the point button here, and it will return a single slice of liver segmentation here. So remember that here, our model is 2.5D, it's not the 3D, fully 3D. So for point prompt here, so we can show that when you are editing a single slice on the X-ray view of the CD volumes, you can get a single slice predictions. For example, let's try another organ, like let me see. Let's see the aorta here. So we can place a control point and click the point, and it will return us a aorta segmentation, a single slice. And we can also like place multiple control points here on the view. It can return us like multiple slice inference. And let's clean this scene here. So the other cool stuff is there's a everything button here. So if you click the everything button, the model will inference like everything, basically everything in the model is trained. You can see here, like you could get like a lungs, every organs of the muscles here. So so everything the model is learned, so it can give us the segmentation predictions. Okay, so let's clean this everything segmentation here. So another stuff is we also support a single point inference, control point inference. For example, so we do not give any semantic here. So once we place a control point here, like whatever this muscle is, probably we don't know what type of muscle. Like we place a control point there and we click the point, it will give us a segmentation mask without any semantics. And we can also place another, like, for example, we don't know which organ is this. And we can place a control point like that, and we click the point, and it will give us the segmentation like prompts, returns or segmentation max as well. And also you can edit the segmentation by the segmentation segment editor here in the 3D slicer and the plugin. And also you can add a class, like for example, whatever this brown segmentation looks like, you don't know what its semantic is, you can also create a class here. So in the future, we are going to promote this, like developers may need to promote this zero shot or few shot or fine tuning capabilities with this experience. But now here we see that the inference pipeline is like we support the point prompts and class prompts. And also we have the 2.5D model ready and everything you can see. Okay, so let's go back to the slides. So for quickly get started, as we mentioned, we integrated with MONAI label. So you could quickly go like run with pip install with MONAI label and git clone or Vista repo, and you can get the MONAI Vista and MONAI label sample apps there, and you can also download a sample dataset as we are demoing here, and you could run the MONAI label server with this command. So here's a qualitative like demo of what kind of whole body CT scans segmentation that we can achieve currently. So like head and neck, the lungs, like the abdomen, the pelvis, or like more upper areas of the body. So in the future, we are going to integrate it like as much classes as possible, so that we can achieve like segment anything like the goal. So yep, so let me stop here. So and summarize here the MONAI Vista, which we are providing an open source platform for fast developing prompt-based medical segmentation foundation models. So we are making the we already make the repo public, and you can see that within this Vista infrastructure, so we can achieve like a fast deploying the machine learning, deep learning research models, like especially for the prompt-based models or medical foundation models that we can run with inference and auto segmentation, or we can do manual correction or interactive learning. And also, especially most important is the prompt-based, like the classes, the prompts, or maybe the box in the future. Yeah, so I'm thinking we are still developing and more are coming. So for viewers, we are integrating like OHIF at the same time. And OHIF and or Arsenic are web-based viewers that users can use. And also we're developing digital pathology site like with the QPath. And for imaging modalities, we're going to integrate as more type of image, for example, the MRIs. And also we're finalizing or tuning or fine-tuning pipelines in the future. And like welcome like any more models developing and contributing to the to the repo. Okay, let me stop here and hand it to Michael.
Perfect. Thanks, Yucheng. Let me go ahead and share on my side here. So the last thing I wanted to leave you guys with is for MONAI Vista, we have two different things. So one, just like Dave said, is that it is publicly available as of today. So if you haven't seen it or you do Google search for it, you probably won't find a lot about it. But I did put the links both in Discord and in the Zoom chat. So take a look at it there. It's also here. If you go to github.com/project-monai/vista, you can find everything on there that they've been talking about today. The other thing I want to mention is that we have a MONAI Vista collaboration survey. So I have a QR code here on the screen and a link here to the survey. I'll put that link in chat here after I'm done. But the idea is that we're seeking for collaborators to help train the model with additional data. So right now there are, they mentioned earlier that the total segmentator data set is the base model that's being used. There are other data sets that are being looked at to have multi-data sets to help extend the model. But we need more data than that. And so we're looking for collaborators who are interested in providing data, algorithm training, and or development and validation of the model in preclinical evaluation. We're looking for both annotated and possibly non-annotated data, but with the ability to annotate preferred. But if you have any data available that you think might be useful to this, please let us know and fill out the form. And for institutions who aren't able to share their data publicly, we are looking at setting up a federated learning collaboration to be able to have the data again stay locally at your own sites, but still contribute to a larger global model. Just like Holger was talking about in the session before this with federated learning, we're trying to take advantage of that because we know that not all the data can be just easily exported out of your institution. And so we're looking at that, setting up that infrastructure and figuring out how we can get people involved in training a better, bigger model for MONAI Vista. Some of the benefits for being an early phase collaborator, if you do end up collaborating and helping in this process, is on the NVIDIA side of things, we have expertise there that can help you customize this foundational model to hopefully your workload or things that you're working on and our general tooling infrastructure. One of the other things in that survey that we're asking, and I'm part of the team who's helping with this, is having a demo that we can stand up for you to test it out in its current form. Right now we have an OHIF plus Vista demo that is almost done, and that we'll be able to stand up on an AWS instance, send you a link. It's not publicly available right now because we don't have the infrastructure set up to scale that yet. But if you are interested in collaborating and you do want to see a demo, fill it out. In the survey, there's a question that says, I would like to see a demo of it, and can we contact you to set up that demo experience? Click yes on both of those, and we will contact you here in the next few weeks and set up a time for you to be able to see the demo set up with OHIF and Vista in that sort of experience there. But I will put these again in there in chat here in a moment. But please, if you're interested, fill out the survey, and it would be a great help to helping further this effort for MONAI Vista.